Alright guys, welcome to part 2. YouTube only lets me upload 10 minutes at a time, so that's why we have 2 parts for this. But hopefully you finished already taking notes for this first section. We're going to go through some steps for graphing in standard form, and then we'll do a couple of examples. And once we're done with this, the only other thing that you all have left to do today is to get working on homework 3. So let's kind of summarize everything we just did in that last problem and write down just a couple of steps on how we can graph when we're in standard form. So the very first thing that we need to do is identify the stretch, just like we did earlier, right? Just like with vertex form. So this is the value or the number before x squared. So it's not necessarily, I don't love to say that it's the first number in our equation, because sometimes we can write quadratics like this, kind of backwards. And then we still need to look at the number before our x squared to figure out if we have a stretch or if we're opening up or down. Okay, so stretch, this is the number before x squared, and this is our a value when we go to put this equation in graphing form. Okay, second step is to factor or use our quadratic formula to find our x-intercepts, just like before. Sometimes we'll be able to factor right away, right? We're really good at factoring when our a value is 1. If it's not, we either need to figure out a way to factor out maybe a constant, or figure out another way to factor, or if all else fails, we can always use quadratic formula to figure out our x-intercepts. So step 2 is to factor or use that quadratic formula to find the x-intercepts. And once we have those, we can go ahead and stick them on our graph. Okay. Third step is to find our vertex. And we know that the vertex is halfway in between. Our x-intercepts, right? And if we're having trouble figuring out what that halfway number is, we can always find the average of our x-intercepts, right? So if we want to find that average, right, that was one of our x-intercepts plus our other x-intercept divided by 2. Okay, and this is going to give us our x-coordinate of our vertex. Okay, step 4, we got to figure out the y-coordinate of our vertex as well. So we will take that x-coordinate of our vertex and plug it back in to our equation to find that y-coordinate. So basically at this point, all of our steps that we did last unit when we were graphing in standard form are exactly the same. Okay, the only difference here really in this chapter is that maybe factoring might be a little bit more challenging, and that I want you to write your equation in graphing form. Okay, so write your vertex as your h comma k, and put all of your information. So you need your h, your stretch, and your vertex into graphing form. Okay. Last step would just be, if you haven't already, graph everything. And the cool thing about putting this back into graphing form, right, is we learn how to get some more accurate points from that. We learned our pattern. If we take our vertex and we go out 1, we know on a normal x squared graph, if we go out 1, we're going up 1. And the only thing that changes if we have a stretch is that up distance gets multiplied by whatever our a value was, right? We knew if we took our vertex and we went out 2 units, we would normally go up 4. And again, if we have that stretch, we just multiply that 4 by whatever our stretch was. Lastly, out 3, we went up 9, and same sort of thing. So on our last problem, we could have made a couple more accurate points by saying, okay, we know we have a stretch of 2. So when I go out 1, normally we go up 1. But that stretch of 2 is saying, hey, now we're going to go up 2. So we could have added a few more accurate points. Same thing here. If we go out 2, we normally go up 4, but we need to multiply the 4 by the 2, their stretch. So we're going to go up 8. So really, my parabola should have been a little, looks like a little skinnier. Should have looked more kind of like this, now that I have those more accurate points. Okay? All right, let's do a little bit of practice. So, very first step here is to identify, what do we say? Identify our stretch and if it's opening up and down. So if we're looking at the number before x squared, we have nothing there. Technically, we have a little positive 1. So we know that we have no stretch, or we have that normal width of our parabola, and that we're opening up. Okay. Second step is to factor or use quadratic formula to find our x-intercepts. So let's set our equation equal to 0, and we'll factor this. So let's see, we'll factor that x squared into x and x. We need a number that's going to multiply to -2 and add to -1. Let's see, 2 and 1, and we're going to make that 2 negative and that 1 positive, because -2 plus +1 make -1. And from here, we figure out what makes each of these 0. -1 makes this factor 0, 2 makes this factor 0. Okay, so those are going to be our x-intercepts. We can go ahead and put those onto our graph, and now we need to work on finding our vertex, right? Just looking at my graph, I know my vertex is probably going to be some sort of fraction. It looks like it's probably going to be around 0.5. But let's double check. Let's just find our average to figure out exactly where that vertex is going to be. So we'll add up our x-intercepts and divide by 2. And there we go. We get that our x-coordinate of our vertex is at 1/2. Okay. We're going to take that 1/2 and we're going to plug it in for x up here. Oops. Everywhere we see an x to figure out our y-coordinate. And let me go ahead and calculate this. Let's see. Our vertex is going to be, when we plug in that 1/2 in for x, we should have gotten out -2.25. So this is where our vertex is going to be. Okay, we can place this on our graph. So negative, or 1/2, we're going to go down -2.25. Okay. Our very last step, just for this problem, we can go ahead and connect our dots, right? We could do our outs and ups, kind of like what we did before. We don't necessarily have to, because our x-intercepts and our vertex are pretty close together. So we're able to see what that stretch, or lack of stretch, I guess, looks like. Whereas in our last problem, right, they were spaced very, very far apart. So we needed a couple extra points in between. Our last step here is just going to be to rewrite this in graphing form, right? We have that a minus x minus h squared plus k. We know that we had no stretch, right? Our a value is 1, so we don't need to write anything there. Our h is our 1/2, but remember that always goes in as opposite, and our y-coordinate goes in as the same. So this would be our graphing form version of this parabola. Again, it's the exact same equation, the exact same parabola that standard form makes, just looks a little different. Okay, last question here. Okay, we're going to start the exact same way. We need to identify our stretch. And our stretch is, again, that number before our x squared. So we have a stretch of 2, which means this graph should look skinnier. It's a positive 2, which means we're still opening upwards. Okay. Second step, find those x-intercepts. We're going to set our equation before equal to 0. And again, when we have that a value right here that's not 1, it makes factoring just a little bit harder. But if you notice, just like before, all of these numbers, 2, 10, and 8, are all divisible by 2, right? So if we factor that 2 out, it's going to leave us a quadratic that's just a little bit easier to factor. So we're left with x squared. 10x divided by 2 leaves 5x, and 8 divided by 2 leaves 4. Okay, and now we're going to work on factoring what's left over, this stuff. So our x and our x make x squared, and then it looks like a positive 4 and positive 1 would work to make a positive 5. So we get x equals negative 4 and x equals negative 1. And we can stick those x-intercepts on our graph. Okay, looking for our vertex. If I'm visualizing a middle point, it's probably going to be right here at negative 2.5. That seems to be about the middle. But let's find that average again just to double check that that's actually where it is. So we'll add up, and I'm going to put these in parentheses actually because they're negative and I don't want to make mistakes with that. I'm going to add up my x-intercepts, divide by 2. We get negative 5 over 2. Or like what we kind of predicted, negative 2.5 is the x coordinate for our vertex. Okay. If we want to go back in and find that y coordinate, everywhere we see an x, we're plugging in that negative 2.5. And again, whenever you're plugging in negatives into your calculator, be very careful and make sure that you're putting parentheses around them. Okay, so after you do that, you should see that your vertex was at that negative 2.5, and the y coordinate that you should have gotten is negative 4.5. And so we can go ahead and put that again on our graph. Okay. If we wanted to get some more accurate points, we could, right? If we go out 1, so a total of 1 unit away, we know we normally go up 1. But in this case, with our stretch of 2, that's causing us to go up 2. So I know another point on my graph is approximately right here. When I go out 1 in this direction, I know I need to go up 2. And when we go out 2, normally we go up 4. But in this case, with our stretch, we need to go up 1, 2, 3, 4, 5, 6, 7, 8. So we're going to have a point kind of about right here. And it's approximate because we're not on our grid, so we're just doing as best as we can to visualize. But here is our parabola. At the very least, when you're sketching parabolas, I need to see, just like I said before, x-intercepts and vertex. If you can add in some of those extra points, that's usually pretty helpful, especially kind of around here and maybe a little bit higher than our x-intercepts. Okay, last step here is to just write this all in graphing form. So we knew that our a value, our stretch, was 2, so we're going to put that there. Our vertex was at negative 2.5, negative 4.5. So when we put that x coordinate of our vertex in, we know that that switches sign. And our k value, our up and down transformation, will stay the same. So this is what our parabola should look like in graphing form. So make sure you have all of your notes done. If you have questions from today, write those down in a margin or on another piece of paper and be ready to ask those tomorrow. The only other thing you guys are working on for the rest of class is homework 3. And I'll see you guys tomorrow.